Neural networks are at the forefront of artificial intelligence, mimicking the human brain's ability to learn and make decisions. At its core, a neural network is a complex system of interconnected nodes, or neurons, organized in layers. Each neuron receives input, processes it through activation functions, and passes it on to the next layer, gradually transforming data into meaningful output. This architecture enables neural networks to recognize patterns, classify information, and even make predictions. In this beginner's guide, we'll unravel the fundamentals of neural networks, exploring their architecture, types, and applications. Whether you're a curious enthusiast or a budding AI practitioner, this guide will demystify the world of neural networks, laying a solid foundation for further exploration into the realm of artificial intelligence. Join us on this journey as we delve into the fascinating world of neural networks and unlock their transformative potential. Deep learning is a subset of artificial intelligence, AI, that mimics the way the human brain works by creating artificial neural networks capable of learning from large amounts of data. At its core, deep learning revolves around the concept of neural networks, which are composed of layers of interconnected nodes called neurons. These neurons process and transmit information, allowing the network to recognize patterns and make decisions. One of the key features of deep learning is its ability to automatically learn hierarchical representations of data, where higher-level features are derived from lower-level ones. This hierarchical learning enables deep learning models to extract complex features from raw input data, making them incredibly powerful for tasks such as image and speech recognition, natural language processing, and more. By understanding the basics of deep learning, including neural networks, activation functions, and optimization algorithms, enthusiasts can gain insights into how these models work and appreciate their potential for driving innovation across various. Convolutional neural networks, CNNs, represent a cornerstone in the realm of artificial intelligence, particularly in computer vision tasks. These specialized neural networks are adept at processing and analyzing visual data, making them invaluable in tasks such as image classification, object detection, and facial recognition. What sets CNNs apart is their ability to automatically learn hierarchical patterns and features from raw pixel data through a series of convolutional layers, pooling layers, and fully connected layers. By leveraging local connectivity and parameter sharing, CNNs excel at capturing spatial dependencies within images, enabling them to discern intricate patterns and nuances. With applications spanning from autonomous vehicles to medical imaging and beyond, understanding the architecture and workings of CNNs is fundamental for anyone venturing into the exciting field of computer vision and artificial intelligence. Recurrent neural networks, RNNs, stand as a cornerstone in the domain of sequential data analysis, exhibiting remarkable prowess in tasks requiring an understanding of context and temporal dependencies. Unlike traditional feed-forward neural networks, RNNs possess loops within their architecture, enabling them to maintain memory of past inputs. This capability makes them exceptionally suited for tasks such as natural language processing, speech recognition, time series prediction, and more. With their ability to process sequences of data and retain information over time, RNNs have found applications in various fields, including machine translation, sentiment analysis, and handwriting recognition. However, challenges such as vanishing gradients and memory limitations have led to the development of advanced RNN variants like long short-term memory, LSTM, and gated recurrent units, GRUs, which mitigate these issues and further amplify the potential of recurrent networks in modern artificial intelligence. In the quest for cognitive excellence, AI emerges as a formidable ally, transcending human limitations in performance benchmarks. By harnessing advanced algorithms and machine learning techniques, AI systems not only match but exceed human capabilities in various cognitive tasks. From memory recall to pattern recognition, AI showcases unparalleled accuracy and efficiency. Through iterative learning and data-driven insights, AI continually refines its strategies, pushing the boundaries of what was once deemed exclusively human expertise. This symbiotic fusion of human intellect and artificial intelligence heralds a new era of achievement, where the amalgamation of human ingenuity and machine precision propels us towards unprecedented heights of cognitive achievement. As AI continues to evolve, it promises to revolutionize our understanding of intelligence and redefine the benchmarks of human cognitive prowess.